All right, well, hello AFDA students. Welcome to our video lesson 17, which is on evaluating functions and function notation. Our objective for today is evaluate functions with some function notation and inputting some domain. So we're going to deepen our understanding about what domain is. And right now you guys know about what a function is. We'll review that with you here today. Something that you may not know is something called function notation. And we've got our feet wet with domain and range a little bit. So remember what a function is over here. A function is a relation in which each element of the domain is paired exactly with one element of the range. So what I told you last lesson is that you can't have a repeating x with a different y value. Okay? So let's take a look at more with functions here today. Let me slide down here and see what we have in example 1. So example 1 says this. It says compare the following tables and then graph your points, or says complete, the following table. So we have this function rule, if you will, here, y is equal to 2x minus 1. So all we have to do is input these in here. So if I input this -3, 2 times -3 is -6 minus 1. That's going to be -7. 2 times -2 is -4 minus 1 is -5. 2 times 0 is 0. Minus 1 is -1. 2 times 2 is 4. Minus 1 is 3. And then 2 times 4 is 8 minus 1, which gives you 7. So let's go down here and graph these. So we have -3 and 7, which is going to be right about there. -2, -5, which is going to be right in there. 0, -1. 2, 3. It's right about there. And 4, 7, which is up in that area. So if we clean up these points a little bit, make them a little bit neater, you know that this guy right here is sort of representing a line, if you will. Let's look at this function rule here. Have some inputs and outputs going on here, some x's and y's. So if we square -2, we get 4. Square -1, we get 1. Square 0 remains as 0. Square 1, we get 1 again. And 2 squared is 4. So let's graph these guys here real quick. We got -2 and 4. We have -1 and 1. We have 0, 0, 1, 1, and 2, 4. So this guy might look familiar to you. We haven't graphed something like this in a while. That's more of a U-shaped graph. And remember what these guys look like. If you go to the top right-hand corner up here, over here, I'm going to ask you in a moment, what did you notice about the second graph that's different from the first graph? Well, the second graph is not linear. I'll write that in for you in a second. But if you remember our vertical line test from our last lesson, we take maybe a pencil that's here on the board and we move that vertical line across the graph. It only intersects these guys one time as we move it across. So we know that both of these graphs, or both of these are functions. Okay? So let's head on over there and fill that in. Okay? So it said, what did you notice about the second graph that was different than the first graph? The second graph was nonlinear. Okay? Let's spell that right. But they were both functions. Okay? So both of them were functions because we tested those. Okay? Now notice that each of the equations that we use to complete the table of values over here can be identified as a function rule now. There's another way, though, that we can write a function rule okay, and write something as a function, all we have to do over here is replace those y's with something called f of x. So I'm saying that f of x. Okay, so y equals 2x minus 1 can be written in the form f of x equals 2x minus 1. Again, the x is still the input, but f of x is going to be your output. So basically what we're saying is y and f of x can be the same thing. So let's figure out why this f of x situation exists. So let's look at example 2. It says evaluate the following. So it says f of x equals 3x minus 2. Remember, we could have a y there, but here's what it's asking. It says find f of 4. So notice that the 4 replaces the x. So we can write this over here. We could say that f of 4 is going to equal 3, not times x anymore, but times 4. And we could put our minus 2 on there. So f of 4 would equal whatever 3 times 4 minus 2 is. I think that's going to be 10. So that's what f of 4 is. So what happens here, folks, is this is just a shorthand way of asking you to input 4 where the x is. So likewise over here, if we have f of x, this function rule equals negative 5x plus 7, and we want to know what f of negative 2 is, you replace the x with negative 2, so that's what you're going to do right here. So if you were going to type this in your calculator, you would have negative 5. In parentheses, you would have negative 2. And then you would add your plus 7 on there. So you would come up with a 17 there. Now, same game going on here. F of negative 5, if you plug negative 5 in there, whether you put it in your calculator, put it in parentheses if you're doing it that way, you might wind up with 27 for that one. And for this one here, notice that we have right here, not f of x, but h of x. So you can have different variables in here in function rules. They don't always have to be f and x and all those things. You can have some different letters in here, even for x. But we're going to replace that x with a negative 2, so you really have 4 times negative 2 plus 6 is what you would type in your calculator. And I think that works out to be negative 2. So this is called function notation, this f of x stuff, where it replaces the y. Okay? So let's answer this last question here. It says, what would f of x equals x plus 2? What would happen if you had f of 3 in there? If you plugged in 3 right here for where the x is, you'd have 3 plus 2. That would equal 5. What would happen if you wanted to write that as an ordered pair? Well, 3 is your x value, or your input, and 5 would be your f of x value, or your y value. So you could write that as an ordered pair. Now, on the home stretch here, let's look at example 3. Example 3 says we're going to work with some domain, and domain is your set of input values. So remember, we organized that in a chart, and I think last time I put a little x under there. So it says given f of x equals x squared minus 4, and a domain of, notice the set notation here, negative 2, 0, 1, and 4, find the range. So what these numbers are going to be your input. So one at a time, anywhere there's an x, which you only have at one place here, we're going to input that value right here. So we're going to start with negative 2, put that in there. So if you're using your calculator, you might have put that in parentheses, have negative 2 squared minus 4. And what would you get for your output there? So your output, let's see, negative 2 squared is 4. 4 minus 4 is 0. The next thing you would input here is a 0, so you could just put that in there. 0 squared is 0 minus 4. Your next output, if we put 0 in there, would be negative 4. You could keep on going. You put 1 in there. 1 squared is 1 minus 4. That's going to be negative 3. And then lastly, you put 4 in there. 4 squared is 16 minus 4. I think you're going to get 12 there. Now, sometimes, class, they rewrite these in some type of order, maybe like least to greatest, so don't let that bother you if the answer is written differently. It has the same members of the set, but they put them in, let's say, least to greatest as far as that solution set goes. So please don't let that bother you. So again, just domain is things you're going to input and you're going to get outputs. If the output repeats itself, you don't have to list it twice. So here's what you know. Can you write your domain and range as ordered pairs? So could you come in here and say, my first input is negative 2 and my output is 0? Sure you could. You could organize those, put negative 2, 0. So the answer is yep, you sure can. You guys can do that. Could you organize these as a table of values? Sure could. Yep, for that. And then if you had your ordered pairs or your table of values, could you graph that? Obviously the answer is yes, you can. You've already done that. So again, understanding function notation, some domain and range today are some big items. Guys, that's all I have for you. Please ask questions if you have them, and we'll get some practice here with the try problems in a moment.